Hold on to your hats. We're on for a wild ride with Unit 5 and Unit 6 on triangles. More triangles. Alright, so the first one we need to talk about vocabulary, which I know a lot of you will enjoy restudying for the quarter test. So the first section is just giving you a bunch of segments and asking for those. For the most part, we're okay on that. Number 1 is called your median. Remember, a median connects a vertex to the midpoint of the opposite side. Then we have the perpendicular bisector. So perpendicular means it makes a right angle, and bisector means it bisects that side. It may or may not go through a vertex. So sometimes my median is the same thing as a perpendicular bisector, but not all the time. Okay. The next one, it's marking those two angles congruent, so that's an angle bisector. And then last you have a right angle connected to the vertex, so that is called my altitude. Alright, so the next section is looking for me to connect, so I'm going to start with the pictures. So this first one, I noticed there are the angle bisectors. Angle bisectors are concurrent at the end center. So A is going to be my end center. Okay. Then I notice right angles that are being connected to a vertex. So those are my altitudes. And altitudes are concurrent at the orthocenter. Alright. Then I have perpendicular, but they're also bisecting or going through the midpoint, which means that they're my perpendicular bisectors, and perpendicular bisectors are concurrent at the circumcenter. And then hopefully that means the last thing is going to be where my medians are concurrent, which is my centroid. So medians mean we're talking about the centroid. Alright, just some straight up memorization we have to do for that part. Okay. Oh look, we already talked about this. So perpendicular bisectors intersect at a point called the circumcenter. Angle bisectors intersect at the end center. Medians intersect at the centroid. And altitudes intersect at the orthocenter. You also have some other fun-filled facts to learn as well and remember for the quarter test. Okay, so the first segment we're going to look at, we didn't list above because it doesn't intersect at the same point. It's called the midsegment. And what we need to know for midsegment is that 2 times your midsegment equals the parallel side. So in this one, I have my midsegment is x plus 2. So 2 times x plus 2 equals the parallel side. Distribute and solve like normal, which most of you are kind of getting to where you can do this in your head. So x equals 6. The other way we can ask this problem is to do a perimeter question. So remember, perimeter means to add up all the side lengths. So first I need to find the side lengths. Let's look at what they give me. They tell me that DF is 24, BC is 6, and DB is 8. And it wants to know the perimeter of EBC. Okay, so it needs the little guy. All right. So if this long side is 24, that means the parallel side on the inside is half of that, so 12. And then they already gave me the small piece there, so this one is also going to be 8. So 12 plus 8 is 20, plus 6 is 26. So there were a couple facts for perpendicular bisectors. In this picture, it's telling me that it's a bisector and that it's perpendicular. And what that also meant is that this other side is congruent to the BA. So when it asks what AB is, it's just going to be 4.1. And we could prove that using our different triangle theorems. The other goes in reverse. So it tells me that it's the perpendicular bisector, which means if YZ is 3, that WY is 3, and the question it's asking is about WZ, so that entire length would be 6. Next we have an angle bisector question. I know it's an angle bisector even with them not telling me it's an angle bisector because they have marked these two sides or these two distances as congruent. Then I know that I can set these two values equal to each other. So 2x plus 5 equals 4x minus 25. So 2x equals 30 and x equals 15. Of course, they want me to substitute that in, so I'm going to choose, since they're the same, I'm going to plug it in this one. So 2 times 15 is 30, plus 5 is 35 degrees. Pay attention on this next one, because it's telling me that this is an altitude. Okay, so what does an altitude mean? An altitude means it's making 90 degrees. So I have to find where it's talking about an angle and set that equal to 90 degrees. I do not know that CD is congruent to DB. This is not necessarily a median, even though it looks like a median. So I can't solve that part first. I have to start with what I know, which is that the angle is 90 degrees. So solve this, we get 4x equals 96. So then x equals, dun, da, da, da. Calculators are great inventions that I don't have right now. 24. Okay, so x is 24, and it also wanted me to find these other two lengths. So 24 plus 7 would give me 31. And then 2 times 24 would be 48. And 48 minus 15 gives me 33. So those are not the same, which means I would have gotten the wrong answer if I assumed that those were medians and not just an altitude. All right. The next one says LJ bisects angle KLM. So because it's bisecting, that means that these two segments are congruent. Once again, we could prove that using our different triangle congruence theorems, and we did in class back in the day when we first learned this. So we can set those two expressions equal, we can solve it, and then it's asking for my other values, so I get 12 plus 5 is 17, and these should be the same because that's the entire point of the problem. All right. Last one is they give me that AB is a median, so CD is 18, and BD is x minus 6, and it wants me to solve for x. So there's two ways you could do it. The easiest way is to see that if the entire length is 18, that means that this little guy is 9, so x minus 6 equals 9, and x equals 15. All right, now let's talk about the centers, where these different things are crossing and their properties. So the first diagram is talking about perpendicular bisectors, and the first thing it wants me to do is find BD. BD. So that's this right here. So that's going from the vertex to the circumcenter, and the distance from the vertex to the circumcenter is congruent. So I just need to find another one of those same distances, which is 11.5. The next one is asking us to find DC, which is the same thing. So 11.5. Now, it could have also asked something like, what is GC? And I would just take the 21 and divide by 2, and that would give me 10.5 if they asked me about that, because we're talking about a perpendicular bisector. Next, we're looking at an incenter. Remember, an incenter is where the angle bisectors cross, so we're going to be using that. And the incenter is equidistant from the sides. So this first one asks for MU, which is going from the side to the center. So I need to find another spot that's going from the side to the center, which would be 5. And I'm going to go ahead and do the angles. We're not going to worry about number 8. We have to use Pythagorean theorem for that, which is fine, but we're going to move on with our life. All right. P, H, U. Well, they gave me the left part is 21, so that means this is 21 degrees. And then U, G, M. So they gave me the bottom part's 28, so that means that this is also 28. All right, now we got some centroid stuff. So for centroid, remember what we want to use is that we can either go from the total length to the short side by dividing by 3, or we can go from the short segment to the longer segment by multiplying by 2. So if we want to find YL, actually I'm going to label all this stuff first. Let's see, we have YP is 12, LX is 15, and LZ is 18. Okay, so LY is here. And since these are medians, that means that those two segments are going to be congruent. So that is also 15. If we want to do YN, okay, so we're given the longer piece. So I want to divide that by 2, so I get 6. And my total distance is 18. And then LP, so that one gives me the total distance is 18. So I divide 18 by 3 and get 6 for the short distance. All right, now for the trickiest part, which is the graphing, okay? So what we need to know for graphing is we have to make sure you know the definitions of the centers. So centroid means I'm looking for the median, and the median connects a midpoint of a side to the opposite vertex. So I only need to do this with 2 sides. I'm going to do the one on the left first. So I just find the midpoint, and you can do this visually, and connect it to the opposite vertex. And then I'm going to do the one on the top, the midpoint. I see there are 4 units to the horizontally away from each other, so I'm going to go 2 units, and that is going to be where that midpoint is, and I can go straight down. And those are intersecting at the point 8, 5, so that's where the centroid is. That one is probably the most straightforward one, and I had the most correct answers for that. But let's look at orthocenter. So we have -5, 4, and remember, I'll give it to you already being graphed. You're welcome. And 1, 4. Okay. I will probably need to draw straighter lines in a second for this. Okay, so I'm going to start. I see we have a horizontal line. Yay! Horizontal lines are really nice. Because if it's the orthocenter, that means I need perpendicular lines. And perpendicular lines have opposite reciprocal slopes. Opposite reciprocal slopes. But if I'm dealing with a perpendicular line, or sorry, a horizontal line, then perpendicular, that's going to be vertical. So if I'm looking at this side, I need to go to the other vertex, and I'm going to draw a vertical line from there. Now, this is an obtuse triangle, so that means that my orthocenter is going to be outside my triangle. Okay. Now, I notice that the side right here, I need to find its slope. I have to go down 7 and right 1. So then my perpendicular slope to that side would be up 1 and right 7. So I'm going to go from the other vertex up 1 and to the right 7, which is going to intersect right there. Do you see it? So these are intersecting at the point 2, 5. So you have to know whether you're finding midpoints or whether you're dealing with perpendicular slopes. If I want the circumcenter, that means I'm going to do both. I'm going to find the perpendicular slope to that side and go through the midpoint versus through a vertex. Now for the section we like. In triangle fun, see what they did there? UN equals 10, UF equals 16, and FN equals 14. Which angle is the smallest? So we want to sketch our little triangle. Isn't that fun? You get it? Fun? Okay. FUN. My stylus is giving out on me. It's tired. So UN is 10, FU is 16, and FN is 14. So smallest side is opposite smallest angle, so that is going to be angle F. In triangle hat, angle A is 47, T is 93. List the sides in order from least to greatest. So they only gave me 2 angles, which means I need to, find the third, which is going to be, let's see, 40 degrees. And let's put them in least to greatest. So smallest is going to be AT, then HT, then AH. Okay. Could the following be lengths of triangles? Remember, that's where we're going to add the 2 shortest sides. So 5 and 9 gives me 14. So yes, that's a triangle. Add the 2 shortest sides. 7 and 14 gives me 21. So yes, that's a triangle. 1 and 5 gives me 6. And since 6 is less than 7, that's not going to work. 2 plus 2 is 4, which is bigger than 3, so that does work. All right. If one side of a triangle is 17 centimeters and the second side is 39, what are the possible side lengths? So this is asking for our range. So on the left, we're going to subtract. So 39 minus 17 gives me 22. And then the right side we add. So 39 plus 17 is 56. My last topic we did this quarter was similar triangles. So remember, for similar triangles, we have 3 theorems: angle, angle, side, angle, side, and side, side, side. But unlike with congruent triangles, we're not saying that the sides are congruent, we're saying the sides are proportional. So looking at the first one, I don't have any angles, so that means it's trying for me to see, are these similar by side, side, side? And when you're trying to do similarity by side, 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 it's like you're going through the drive-thru. Small, medium, large. Small side on the left is 6. Small side on the right is 12. Medium side is 10. Medium size is 20. Longest is 15. Longest is 30. And all of those are going to reduce to 1/2. So these are similar by side, side, side. Going to the right, I notice I have a bow tie, but they've already marked that that angle is congruent. So since they didn't tell me these are parallel lines, I can't assume they are, which means these are not necessarily similar. All right. Looking at the next one, since I don't know that these are similar triangles, I can't do the kind of top over bottom like we do when we're solving. I need to look at my small triangle. So my small triangle has a side of 4 over the length of my big triangle would be 7. And does that equal 4 over 7? Yes. And since both the little triangle and the big triangle share a vertex, which is in between those 2 sides, this is going to be side, angle, side. The next question is a bow tie, so I can add those vertical angles. And now I have 2 angles in each triangle congruent to the other. So these are similar by angle, angle. Next, I notice I have 3 sides again, so we're going to see if this works with side, side, side. Small, medium, large. Short is 48. short is 8, medium is 72, medium is 12, long is 84, over long is 14. So I notice these are both 6, and believe it or not, I don't have my 18s times tables memorized. Oh, it does equal 6. Isn't that great? So we have side, side, side. Yay! All right. What do you think we're doing in the next one? The same thing, because I have 3 sides. So we're checking small, medium, large. Now it's a little weirder because I have the same length in both, but just pick where you want to start. Nobody cares. 5 over 6 equals 5 over 6 definitely does not equal 7 over 8. So these are not similar. All right. Now we're checking for side angle side again, because we have little triangle, big triangle that are sharing those angles, and we're going to check the sides. So we need to check small, see if it is equal to the large. So short is 2 over the long length is 6, and see if that is equal to 3 over 9. And both of those do simplify to a third. So these are similar by side angle side. And last one, we have little triangle, big triangle, and they both have that angle. And it already gave me a right angle. So these are similar by angle, angle. Okay, let's finish up with some solving. Don't get tripped up by the fact this problem has 35 degrees in it. Nobody cares. Cross it out. Doesn't really affect you. It was just to be there to help us with knowing that they're similar and where these marks are. Okay, so I'm just going to call this little question mark x. So I'm going to do x over 33 equals 28 over 42. Now, I don't have a calculator, so I'm going to go ahead and reduce this fraction to make my numbers a little smaller. So both of these are divisible by 7. So that gives me 4 over 6. I can reduce that some more to 2/3. Once again, I'm just doing that so I can do these in my head. So 3x equals 66 and x equals 22. Gonna add an x where my little question mark is. I need to make sure that my pieces are matching up. So if I want to find x, I know I need to put it over the other side here. So let's do x over 18. But the only other piece I have on this side is this whole 12. So it equals 12 over, I need that entire distance, which would be 24. Once again, I'm going to simplify that to 1/2. So 2x equals 18 and x equals 9. Sometimes we're going to need a little bit more work for cross multiplying. So here I'm going to get that x plus 3 over 3x plus 1 equals 6 over 15. I'm going to reduce that to 2/5. I need to make sure I put parentheses. So 5 times x plus 3 equals 2 times 3x plus 1. So 5x plus 15 equals 6x plus 2, which means x equals 13. It asked about AB though, so I need to substitute that in. So 13 plus 3 would give me 16. All right, CAT is similar to PIT, so that order is going to be important in a second. So I'm going to do 20 over 35 equals 8 over P. So 4P equals 56. So P equals 14. With word problems, the most important thing is to draw a picture. A tree with a height of 4 meters casts a shadow that is 15 meters long. How high is another tree that casts a shadow 20 meters long? So 4 over x equals 15 over 20. So 16 equals 3x. So x equals 16 over 3, which is about 5.3 repeating, I think. A 40-foot flagpole casts a 25-foot shadow. Find a shadow cast by a nearby building. It helps if I can read the rest of the problem. That is 200 feet tall. Clearly not to scale. So 40 over 200 equals 25 over x. So x equals 125. A girl who is 160 centimeters tall stands 360 centimeters from a lamppost at night. Her shadow from the light is 90 centimeters long. How high is the lamppost? So 160 over 90 equals x over, the important part of this problem is to make sure you put the entire distance. So 450. That whole part right here. All right. I'm doing all this by hand, but you guys have a calculator, so this is less of a big deal for you. 90 goes into 450 5 times. So x equals 800.